Hello dear students, this is a revision lecture from chapter 10 Gravitation, first half only. So we are going to study about weight and Newton's law of gravitation only. So let me give you a brief and quick revision. What is gravitation? Gravitation is the fundamental force of attraction between any two masses present in this universe. This force is directly proportional to product of masses and inversely proportional to square of distance. This law was found by famous scientist Newton and it is known as Newton's law of gravitation. When we remove the directly proportional sign, there comes a constant capital G, which is known as universal gravitational constant. Let us understand it by an example. Find the force between two 100 kg masses at 10 meter distance from each other. So you can see the formula is G m1 m2 by r square. So m1 is 100, m2 is also 100 and r is given 10 meter. And in formula there is square of r. Hence we put 10 square. So this 10 square is 100 and 100 will get cancelled. And the value of G is 6.67 into 10 raised to power minus 11 into 10 raised to power 2. जब बेस सेम होता है तो पावर ऐड हो जाती है, तो -11 और +2 तो पावर बचेगी -9. तो 6.67 इंटू 10 रेज टू पावर माइनस न्यूटन फोर्स हमारा आ गया 200 kg के मासेस के बीच में जो 10 मीटर के डिस्टेंस पे हैं. ग्रेविटेशनल फोर्स इज ऑलवेज अट्रैक्टिव. If you will look at the formula and if we will put, okay, look here, we know that formula is equal to F is equal to G m1 m2 by r square. So if your m1 is 1, if your m2 is 1 and your r is also 1, so all these terms will become 1 and F will become equal to G. So if the unit masses are used with the unit distance, then force of gravitation becomes equal to gravitational constant. You can also define gravitational constant using this relation. It is the force between two unit masses placed at unit distance. So gravitational force is also known as weight. When it is between an object and a planet, then it is known as the weight of that object on that planet. Considering object mass small m on surface of earth, force or weight is given by G mass of earth into mass of object divided by radius of earth का square. And this quantity in this relation G mass of earth divided by radius of earth square is constant and known as acceleration due to gravity. We represent it by small g. So small g is equal to capital G mass of earth divided by radius of earth square. And you can also write it like weight of object is mg, because m is different and g me by re square is known as g. So that is weight, and alone m is mass, so there is a difference between mass and weight. The value of G for earth is 9.8 meter per second square, and G will be different for different planets considering their mass and radii. Radius of earth will be doubled keeping the mass same. What is the new value of G? If we need to calculate, then it will be 4 times lesser. Pay attention here. If we will double the radius, then we are having square of radius here and it will become 4 re square, and G me by 4 re square is our original G, so new G will become G divided by 4. Similarly, on moon, acceleration due to gravity is 1/6 of acceleration due to gravity on earth. You can use this relation for finding the weight of given mass on moon. Then there is a comparison between mass and weight. Dear students, mass is a scalar quantity while weight is a vector quantity. Mass remains constant throughout the universe while weight changes from planet to planet. And mass is the measure of quantity of matter. Weight is the measure of gravitational pull. Mass do not change if you will go at some height or if you will go into the earth. But weight will change. Okay, so these are a few differences between mass. Unit of mass is kg while unit of force is Newton. So these are a few differences in mass and weights. One more point about G. You know, the shape of the earth is little elliptical. The polar radius is less than equatorial radius. Polar radius is small and equatorial radius is large. Hence value of g at pole is more than value of g on equator. It is minimum on equator and it is maximum on poles. With height and with depth both g decreases, because if you will go down the effective mass will become lesser, and if you will go at a height the inverse the distance increases, and we are having g inversely proportional to distance. So hence g decreases with both depth and height. At the center of any object or planet, g becomes 0 because effective mass is 0, which is working on that, for which is working for gravitational force. Also at infinite distance g will also become 0, as we are having r square in the inverse relation. So it was a quick revision. I hope it will help you uh, making your concepts revise and giving you good marks in your test. Thank you.